In this video, we're going to keep talking about parametric equations. In this case, we're going to eliminate the parameter, learn how to eliminate the parameter in equations. So in this case, we have to eliminate the parameter in this equation, right? And this equation. Let me use different colors for this one too. Okay, so now, if you look at them, you notice that this one, it's a little bit easier. This is like a linear, right? And this is quadratic. So this one is going to be easy to manipulate. So we're going to take this one and we're going to isolate t. So we have y, it's equal to 2t minus 1. And we're going to isolate t. So if we are subtracting 1, if you remember, we need to add 1 on both sides to get rid of this one. So we get y plus 1 equal to 2t, right? And now that we are multiplying that t by 2, we need to divide on both sides by 2, right? So these two are gone. And we get as a result y plus 1 over 2. It's equal to t, right? This is t isolated in the easiest of them two. Okay, now we're going to take this value and plug it into this one. So how are we going to do that? We take the equation, so we have x equal to t squared plus t. We're going to replace this value of t into this equation, so we get parentheses to the power of 2. That's for t squared. So and we're going to plug in the value of t. So y plus 1 over 2 plus t. So we're going to add whatever we got as t. And again, it's the same thing. So we write y plus 1 over 2. Now, we can solve this, right? We know how to solve this. So this square applies to the numerator and the denominator. So we get y plus 1 to the power of 2. 2 to the power of 2 is 4. So over 4. Let me fix this equal. All right. Plus, in here, that doesn't happen. So we can just rewrite it as y plus 1 over 2. We can even avoid the parentheses if we want. If you left them, it's fine. Now, you notice that you have two unlike fractions, and you can make them alike. So I need to multiply this 2 by 2 to get the same denominator. And I do it also on the numerator. So now we get this, right? So we get y plus 1 to the power of 2 that we can solve immediately if you want. We can do it immediately. So let's solve that. We have a special product, right? That is like this. A plus b to the power of 2. Like the power of a binomial is always going to be equal to the first term to the power of 2 plus 2 times the first term times the second term, a times b, plus the second term to the power of 2. So we can apply that here. So the first term to the power of 2 will be y to the power of 2, right? Plus 2 times the first one times the second one. So 2 times y is 2y times 1 is 2y. So plus 2y plus the second term to the power of 2. So 1 to the power of 2, it's 1, right? This is over 4. Plus, we multiply this by 2 to make them to make the two fractions alike. So 2 times y is 2y. 2 times 1 is 2. Over 2 times 2 is 4. So now we have the same denominator. So we put the same denominator and we just add whatever we have on top. So y squared doesn't have like terms, so we just rewrite it. But we notice that this guy right here, 2y, it's like terms with 2y. So 2y plus 2y is 4y, so plus 4y. And we also notice that this one right here with these two are like terms because they're numbers. And 1 plus 2 is 3, so plus 3, right? So we know that x is equal to this. It's not really common that we leave our answer like this. We usually write it as a fraction. So x is going to be equal to 1 over 4 y squared plus 4 over 4, it's 1, so 1y, so y, plus 3 over 4, that's 3/4, right? So in this equation, if you notice, we eliminated the parameter. All right, so notice that in this result, we don't have a parameter. We don't have t anymore. We have y, we have x in terms of y. Understood? This is going to be a parabola. You probably know things about parabolas. You can graph this. And if you graph this parabola, you're going to get exactly the same graph as the one that we did in the previous video. So you can do it on your own and check it. In the next example, let's eliminate the parameter on trigonometric equations. So we have this, eliminate the parameter of x equal 5 cosine of t and y equal to 2 sine of t. Remember that we are going to isolate t, but in this case, if you isolate t, you end up with cosine inverse of something. And in this case, if you isolate t, you get sine inverse of something. So in this type of parametric equation, when we deal with trigonometric functions, we're going to isolate each function. So let's start with this one. So x, it's equal to 5 cosine of t, right? So we're going to isolate cosine of t. To isolate cosine of t, we need to get rid of that 5 that is multiplying. So we divide on both sides by 5. So we get that cosine of t, these two are gone. So cosine of t is going to be equal to 5, x over 5, my bad. So now let's do it with the other one. So we're going to solve this one for sine of t. So we have y, it's equal to 2 sine of t. And again, if we want to get rid of that 2, to isolate for sine, we divide by 2 on both sides. This is gone, and we get that sine of t, it's equal to y over 2. All right. What we're doing with this, if you remember from trigonometric identities, you have an identity that relates sine and cosine. That trigonometric identity is the Pythagorean identity. That's sine square of t plus cosine square of t, it's equal to 1. This identity relates sine and cosine. And we have values for cosine and for sine. So we can just replace here. So we know that we are going to have something squared, right? And that something is sine of t. Sine of t is y over 2. So we can just put y over 2, right? Let me fix this parenthesis. All right. Plus something squared. Remember, cosine squared. So cosine is x over 5. So x over 5. And all this is equal to 1. Y to the power of 2 is y to the power of 2. 2 to the power of 2 is 4. Plus x to the power of 2. And 5 to the power of 2, that is 25. 25 equal to 1. Okay, and this, if you already started studying conic sections, this is an ellipse. And you can try to graph this. Okay, this is an ellipse, something like this. Let me do it here real quick. It should be something like this. If you're not studying conics just yet, don't worry about it. You're going to be able to graph this and understand how this represents an ellipse, something similar to this on the left side. If not, you can plug this into any software, GeoGebra, graphic calculator, Desmos, and you will get this. You will get an ellipse like this. Okay, and that will be the graph for this parametric equations. Okay, I hope that this video is helpful to understand this topic. See you in the next one.